And just like I did with the degrees, I'm going to take that and cut it in half. Half of 90 was 45 degrees. But I want to know now, what is 1/2 of pi over 2? Turns out to be pi over 4. A half of a half is always a fourth. So this one is, the red one, pi over 4. So if I'm going around my circle, I could say I have 1/4 of pi, 2/4 of pi, which 2/4 of course reduces to 1/2. Then I could say I have 3/4 of pi. Sometimes my stylus gets really loud and clattery, huh? 3/4 of pi. Over here I have 4/4 of pi, but 4/4 of pi is just a single pi. Then I have 5/4 of pi, and I have 6/4 of pi, which reduces to 3/2, and I have 7/4 of pi, and I have 8/4 of pi, but that's just 2 pi. Then I'm going to kind of ignore those sections I just did in red. So then instead of thinking about cutting each quadrant into 2 parts, I can think about cutting each quadrant into 3 parts. So that I'm going to start here with what is 1/3 of a quadrant, which means 1/3 of my pi over 2. 1/3 of pi over 2 gives me pi over 6. And I showed you a little bit about why I keep switching colors here. But this is 1 pi over 6. And if I go to the next mark up there, I'm going to have 2 pi over 6. But 2 pi over 6 is going to turn into pi over 3. So I just did 1/6. I did 2/6, which reduces to 1/3. I'm doing 3/6, which reduces to 1/2. I'm doing 4/6, which I'm going to reduce down to 2 pi over 3. So that's 4/6. Next I would need 5 pi over 6. And then I need 6 pi over 6, which is just pi. Then I need 7 pi over 6. And I need 8 pi over 6, which just reduces to 3 pi over doesn't reduce to 3 on top, reduces to 4/3 pi, 8 pi over 6. Down here I have 9 pi over 6, which is going to reduce to 3/2. Then I have 10 pi over 6, which is going to reduce to 5 pi over 3. And then I have 11 pi over 6, which doesn't reduce. You might want to notice that all of the green ones were things I couldn't reduce. But the blue ones, like I took 2 pi over 6 and made it into pi over 3. I took 3 pi over 6 and made it into pi over 2. I took 4 pi over 6 made it into 2 pi over 3. I took 5 pi over 6. It didn't reduce, I kept it. I took 6 pi over 6, reduced it down to pi. I took 7 pi over 6, didn't reduce. I took 8 pi over 6, reduced it down to 4 pi over 3. I took 9 pi over 6, reduced it down to 3 pi over 2. I took 10 pi over 6, reduced it down to 5 pi over 3. I took 11 pi over 6, which didn't reduce. Now that I know something about all these radian measures, I'm going to try and draw some angles myself. Here we go. I wrote them in here so I'd have them nice, but still small. Some of them you can look directly and see. I know that Mrs. Franken used to teach, change your radians into degrees, graph it where you know it is, and then change it back for your reference angle. That's just too much work for me, so I don't do that. You can, it's an option. I don't know if her most recent video does that, but one of her older ones did. Each of those is going to start with an initial ray. So I'm going to start by drawing initial rays for everything. And I'm not necessarily going to do them in the order they have here, but that's okay. I know that if I'm looking at radians, over here I have 0 and 2 pi. Over here I have plain pi. So I'm going to start by labeling each of those with 0 and pi, and 2 pi is what I want over there. But I'd like to have a denominator of 4. So I know that 1 pi is the same as 4 pi over 4. And if that's 4/4 to go to here, I need 8/4 to get to there. So over here I'm going to write 8 pi over 4. Just another way of writing 2 pi. But it's easier to deal with it with common denominators, just like when we were doing coterminal angles before. I'm going to do that for every one of these pictures. I'm going to say, start with 0, go to pi, over here 2 pi. But since I have a 3 on the bottom, I'm going to call this 3/3, which is equal to 1. And I'm going to change my 2 pi into double that, 6 pi over 3. I took time, paused, to do the labels for every line. Every time I matched up the bottom of the fraction. 1 pi turned out to be 18 over 18. 1 pi turned out to be 3 over 3. 1 pi turned out to be 3 over 3. 1 pi turned out to be 4 over 4. And for back to the beginning at the initial ray, if this was 4 over 4, I doubled it and called it 8 over 4. If this was 18 over 18, I doubled it and called it 36 over 18. Down here, had 3 over 3, doubled it and called it 6 over 3. Last one, 3 over 3, doubled it and called it 6 over 3. That's how I get the other side. Having those set up will make it easier to see what I'm doing as I go along here. I have to draw 7 pi over 4. If I start drawing here, positive goes up, and I drew it from here to here. I'd have 4/4. If I'm going to go to 8/4, maybe 4/4, then halfway between 4 and 8, this would have to be 6/4. Or some people find it easier to say 4/4, half of that is 2 pi over 4, which is the same as pi over 2 that we have way over there. 2/4. 2/4 2 more fourths, 2 more fourths. We're not actually there yet. I need to get 6/4. I want 7/4. I already drew 6/4. I need another pi over 4. And you might be able to look at it and say, it must be half of a quadrant there. Or you might come over here and say, pi over 4 is half a quadrant. So I'm going to draw another half a quadrant and put my arrow out there. That one is my 7 pi over 4. Let's do number 5. I need to go negative, so I need to go down. If you look at our circle that we already drew, there's nothing there with 18 on the bottom, so we're kind of on our own here. Let me just think about if half a circle is 18/18, then I would say a quarter circle should be 9/18. But since I'm actually working in the negative direction, we will instead call this negative 18/18 and call this one negative 9 pi over 18. I'm looking for negative 5. And if I think about 9 divided by 2, it would be 4.5. And I know it's really weird to think about that, but 4.5 pi over 18 is the exact center of that space. I need to go just barely past the center then. So I'm going to try and draw a line here. It takes me barely past the center, going downward this time. I'm going to have to do reference angles on these guys too. So let me stop and think about how far down did that go? It went 5 pi over 18 down from there. So over here, that's number 5. I'm going to write my reference angle as 5 pi over 18. And even though it's going down, reference angle is a positive answer. What about that blue one we did first? I went 6/4 of the way around here, 7/4 of the way around, and I wanted to go all the way to the end, which is, I wanted to know how far it is to the end. So I'd say, how far from 7 pi over 4 to 8 pi over 4? Just pi over 4. Or looking at our circle, half a quadrant. Reference angle here, just pi over 4. Let's go number 6. I'm trying to draw 7/3. And a whole circle is 6/3. So I know that I'm drawing more than a full circle this time. If I start here, positive goes up, go around this circle. There's 6 pi over 3. I want 7 pi over 3. I've already drawn 6 pi over 3. What's left to draw? So 7 pi over 3 is what I want. 6 pi over 3 is what's already done. That leaves me pi over 3 left to draw. Okay, I'm trying to do this video late at night, and our puppy just refused to be kept out. So now she's here at my feet rattling things around. I know, you usually have to hear me rattle my papers. My stylus makes noise, but now You gotta listen to my puppy too. Okay, I'm not done with that. Don't let me get distracted. I got 6 pi over 3, but I need 7 pi over 3. Let me go up to the original and say, how much is pi over 3? Pi over 3 is about 2/3 of a quadrant there. So I need another 2/3 of a quadrant. How much further did I go? After I'd gone the full circle in purple, I want another pi over 3 more. So my reference angle for this problem is pi over 3. That's how far I am from the nearest part of the x-axis. Okay, last one here. Negative, so I'm going down first. 10 pi over 3, because it had a 3 on the bottom, I choose to make my pi into a 3/3 pi. And I'm going down. We decided if the pi is 3/3, then the full circle, the 2 pi part, is 6/3. I'm definitely going more than that. So I'm going to start with all the way around and see what else I have to do. I have negative 10 pi over 3. This is what I want. What did I already draw? 6 pi over 3 is done. And that would leave me negative 4 pi over 3 left to draw. That's what I have left to do. So I'm going to think about 3/3. 3/3 would be another half a circle. It's not looking great, but it's still spiraling around and it's not overlapping each other, so we're still okay there. So I needed 4/3, I did 3/3. I think that leaves me 1/3 of pi left to go. And we already decided up here that 1/3 of pi is like 2/3 of a quadrant. So I'm going to throw in another 2/3 of this space to take me right about here somewhere. And yep, I'm going to put an arrow on the end because those arrows are required things. You take your homework quiz, you leave off your arrows, you're in trouble. Some people like to put, when it gets complicated like that, some people like to put some extra arrows along here saying, okay, I can see it's going this way, and 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 this way. Because it helps them to keep track of where they're going. Every time I pause, did you lose track of which one was the starting edge and which one was the ending edge? You can throw in those extras if you want to. Now my question is, how far am I from the nearest part of the x-axis? I'm definitely closer to this part than I am to that. So I went from 3/3, I had to go 4/3 up there. So this is pi over 3 for my reference angle. I want you to notice something here. When it had a 3 on the bottom, no matter where it started from, my reference angle was pi over 3. When it had a 4 on the bottom, my reference angle was pi over 4. When it had an 18 on the bottom, my reference angle was not pi over 18. That's a little shortcut for finding reference angle if it's one of these numbers on the circle. If the bottom is 2, 3, 4, and 6, I can say my reference angle is going to be pi over whatever. If you get other numbers like 12 and 18, which some of the ones in our assignment are like that, it's not necessarily going to match up. Okay, I think that's enough. I will work some problems out for you from this assignment, but I may not do it until after the Zoom meeting in the morning, just because maybe I'll just take requests from whoever wants them before I choose which problems to do. Okay. Hopefully you watch this before the meeting so you know what you're talking about.